Okay, everybody. Well, welcome and thank you for joining me on this Friday morning. Who's got the Friday feeling? Excellent. Okay. About a third of the room has got the Friday feeling. I'm going to assume everybody at home is sat in their pajamas and they've already got the Friday feeling as well. So, we are here to look at an evolution of data platform architectures. Lambda, Kappa, Delta, Mesh, and Fabric. This is a lot to do in 50 minutes, okay? When I put the session together, I thought, oh, this is going to be bad. I find talking in a small amount of time much harder than talking in a long amount of time. But we'll see how we get on. And hopefully, as you've gathered, my name is Paul Andrew. I'm the founder, director, technical architect, if you like, of this company, Cloud Formations. We're a UK-based consultancy. I tell my family as an architect, I just draw pictures and do colouring in for a living, and they believe me, so it's all good. So, let's have a think about this then. Lambda, Kappa, Delta, Mesh, Fabric. Now, the order of those probably written in terms of how they were introduced to us as an industry. But I want to try and do things a little bit different in terms of how I introduce them to you today. So this is how we're going to go through it. Lambda and Kappa will squeeze into the middle, but first we're going to look at Delta. We'll look at data mesh at the end, and Fabric is now going to sit in here amongst some of that other stuff as well. But first, a couple of questions for you. Again, to get you warmed up on this Friday morning, right? Easy question, hopefully, for this audience. What is the answer to life, the universe, and everything? 42, right? Can we all agree on that? 42 is the answer. Do we like this answer? I want to say, folks, no, you're wrong. You're all wrong. Especially this guy at the front, he's very wrong. I want to change history, ladies and gentlemen, because as a consultant, I find a far better answer is it depends, okay? It depends is always the answer. Fine. You get my silly sense of humor as well here. Next question then, what is big data? It depends. Yeah, you see? No. I'm going to give you a different one. I like this answer. Any data that you cannot process in the time that you have or want, using the technology that you have. I like this answer that I heard from Mr. Bookwoody. Do we know Mr. Bookwoody? Follow him? Good guy from Microsoft. And hopefully what we've obviously probably come to do with our big data over time as well is distill it into these 5 Vs. In my career, we started with 3 Vs, volume, velocity, variety. And then we've kind of extended it to the veracity and the value as well. But that's fine. Next question, what is the goal of our data solutions? It depends, sure. But we'll go with an answer a bit like this. We'll say that we have our data sources on the left. We want to get some insight from it on the right. Sound familiar? And hopefully, as we know, data becomes information, information becomes knowledge, knowledge becomes power. We want power, yes? I will make these slides available to you at the end as well, unless you just want to take a picture of me, which is also fine. How do we get there, though? Magic, right? Somebody says, just tell me the answer to this, or just do that, or just do this. If they start the sentence with just, they really don't understand the problem. But I think the way we get there is we could say, well, we need a data warehouse. We need something in the middle to help us get there. It's not magic. We still need to do something with that data. And of course, what we've come to expect from our data warehouse over the years is that we will clean, we'll curate, we'll model, etc., etc., etc. All of these words and probably many more as well in order to get to that insight. Now, this is fine. And of course, you know, we're starting out here because this session is about that evolution of how we want to get there. So we'll start here. And then we'll draw ourselves a timeline to think about some Microsoft technologies for a moment. Now, in my career, that Microsoft technology started with SQL Server 2000. Anybody use SQL Server 2000? Version 7? 6.5? Hey, Hugh. Nice. Okay, we've got some people in the room much older than me. Great. So my career started with SQL Server 2000, and of course, then things have come along in terms of that, perhaps say, on-premises journey. And then in February 2010, things got a bit cloudy, right? Cloudy and grey and murky and all those things. But Azure Blue is what we like. And to try and bring things kind of up to date on the end of my timeline here, in May 2023, of course, Microsoft introduced us to Fabric. But we'll get there. Now, if we think about all of those technologies, all of those products and that evolution, what I'd like to think about, what I'd like to say is that, well, the problem, hasn't really changed. We were still on-premises doing that. And then really when things became more blue, if you like, the problem, again, still didn't change. But what, of course, we liked to do was to decouple things. Decouple the compute, the storage, the orchestration. And this was good. So we took that, or at least I took that, and we'll call it my first reference architecture. I printed this off, I showed it to my mum. She was very impressed. She put it on the fridge. It was all good. It was a good day. So my first reference architecture, there are many like it, this one's mine. But of course, we're being overly simplistic. Microsoft also has a picture, slightly different, but Microsoft call this their components of a big data architecture. Big data, as we know, to be relative, basically, but this is what Microsoft then say. And here we kind of have that separation of the data sources, the batch processing, but also that real-time data and stream processing as well. So this is good. I think this is one of those situations where, there's no real wrong answer to it. It's down to interpretation. It depends. But this is that evolution. So let's get back to our agenda then. We've kind of set the scenes a little bit. On our agenda, first let's think about Delta. Now, to be absolutely clear, we're not talking about the changes of the records that you might pull from a source system, not those delta of changes. Delta in terms of something else, Delta Lake. And the way to think about Delta Lake is that we have a database management system, yeah? And what we know and love about that database management system is that it gives us ACID, autonomicity, consistency, isolation, durability. And what we know about that ACID is that it means that we have transactional resilience for whatever we do with that data in that database. Fine. And over the years, again, certainly on my timeline of technology, all of that goodness that goes into that DBMS meant that we could use metadata and schemas and all these other things on here to structure and organize and deal with our data however we wanted. It doesn't matter if you were using SQL Server or Elephant databases or Sea Lion databases, it's all good. All of this kind of maturity is there baked in. Now, what's better than one database? Two databases, obviously. And then what we did is we started thinking about creating that data warehouse, kind of in line with my first very crude picture that I showed you. And we could again say that we have our application data on the left, our data warehouse on the right. We might have described it as our online transactional processing. I might describe it as the offline analytical transactional processing. I like offline more so than online, but as you prefer. And then, of course, we came up with a process that we called ETL, extract, transform, and load. And this was good. ETL is not cool anymore, by the way. We have to change the order of those letters to be cool, just so you know. And that data warehouse meant that ultimately we had that reporting system to do the data analysis. And this is that goal, getting that insight from this. And very much to my earlier picture, this is kind of what we're heading for. Now, we thought about that data warehouse, and then we thought about our big data problem, ultimately. The volume, the velocity, the variety, certainly at least. And what we found was that that database certainly wasn't really handling it. It wasn't handling the semi-structured data. It wasn't handling the volume very well, because it could only scale up. So we thought about using something else. We said, hey, maybe let's use a data lake instead. We added some water into the database. And then we thought, yeah, okay, this helps us to a point. But we thought about all of those things that our DBMS gave us that I called out earlier. And ultimately what we found was that that data lake was lacking in a lot of those things. It didn't do them very well, or it certainly didn't do them very well on its own. Sure, it gave us other advantages, other advantages for scalability and redundancy and resilience, and it could deal with the volume and the variety. Absolutely. But it was just the storage, distributed storage. So what we could say there is that we missed our ACID. This film reference from the film Human Traffic, does that translate for anybody? More film references to come. So to summarize that problem, we could say that data lakes are good, but they lacked some of that basic ACID transactional functionality, as I'll describe it for you for now. What we could also say is, using my table, and at the bottom here, the main one for me is that in our DBMS, we have that storage and compute coupled together within one product, like SQL Server, whereas our data lake is very much decoupled. It is just the storage. Fine. So if this is the problem, the solution's obvious, right? Just enable ACID transactional support for our data lakes. And if we think about that compute and storage in, again, very generic terms, we might have thought about using Hadoop for the storage. We might think about using Spark for the compute. And that's fine, but again, they're kind of decoupled here. What we need is them to come together. Storage and compute working together as friends, as I'm going to describe it. And this was obviously apparent to lots of people. And this is what then gave rise to these series of ACID data frameworks for our data lakes. Databricks gave us Delta Lake. Netflix gave us Iceberg. Uber gave us Apache Hudi, or Hudi. I didn't work for Netflix or Uber, so in February of 2019, this was great. This was exactly what we needed. And what was then even better about it was that Databricks, in April of that same year, made Delta Lake open source. This meant that as data engineers, or as platform engineers if you like, we could now use this open source set of libraries and actually implement Delta Lake as a framework on any instance of Apache Spark. It doesn't just have to be Databricks. Great. So to answer that question directly then, just say to you guys, well, what is Delta Lake? It is this open source storage layer that brings those ACID transactions to Apache Spark for big data workloads. Relative, but certainly for what we need to do. Now for me, working in Azure, we could have used the Databricks implementation of that, what Databricks do with Apache Spark and how they offer it up to us. We could also use some Microsoft implementations of it. And very deliberately here, we're talking, of course, prior to May of 2023. And we could do this using Synapse Analytics. We could do it using Data Factory data flows, which was using Spark underneath. And we could, if we wanted, done it with HD Insight. Sure. Now, ultimately, what it meant was, because this was now an open source project, those two software vendor superpowers, if you like, contributed back, which then meant that Delta Lake went from not just kind of an open source format, but now to an open source standard, something that everybody in the industry is now going to use and want to use, which was great. And, if we kind of roll that timeline forward, what I also found is, and what I also then got asked again prior to May of 2023, do we use Synapse or do we use Databricks? Do we take the red pill or the blue pill? Now, if there was a B-side to this session, that B-side is that I'm going to convince you that Keanu Reeves is actually a data engineer. That's the B-side here, okay? We'll work on it. But the red pill or the blue pill? And of course, the answer would be, well, it depends. And the timeline meant that it depends. Cost, cluster management, integration, source systems, performance maybe, Spark sessions, et cetera, There was a big long list of it depends when customers ask this question. But that's fine, because, of course, we move forward. We move forward, and now we have a green pill as well, a green pill in the form of Microsoft Fabric, which we'll, weave into our conversations as we go. So just to kind of recap and say, well, sure, this is what we were doing. This was fine. There was nothing wrong with it. The goal didn't change. We had a data warehouse. We evolved it into what we call a lakehouse. A lakehouse which meant that instead of our data warehouse just using a DBMS, we now use decoupled compute and storage, but working together as friends because we have that Delta Lake ACID framework in there as well, which means that we can do that transactional processing. What you'll also probably hear me very cynically calling a data ware lake, Delta Beach House Lake, or again, some combination, so I can try and still convince people that I am cool, really. But hey, we get back to my first reference architecture. All good. Now, who likes a lake house? Tough crowd. Do you know who else likes a lake house? Keanu Reeves. Ah, you see. Who is this crazy person on stage? Keanu Reeves loves a lake house. He's a data engineer. Yes, Paul. Let's move on. Lambda and Kappa then. Let's think about this. Now, Nathan Mars came along and he gave us this book and he said, hey, we've still got a problem here with that velocity. What do we do with it? What do we do with it in terms of our platform and our processing? And he said, let's take the batch data that we have, let's take the speed data, let's separate them out in terms of that ingest, but then let's bring them together when we want to serve them. And we'll handle this in different ways, and we can query it together. This was great. This was absolutely what we needed, because we had to separate them, just because that velocity, in some cases, was so high. Data was just now being thrown at us in any format. So he says, yeah, batch and speed. Do you know who else likes speed? Hey! He's a data engineer. I promise you, he's a data engineer. So in 2015, approximately, in the days of Nathan Mars and what he gave us, he said, sure, let's use Hadoop, let's use Storm, let's do some querying, etc. And this was fine. This was not bad, this was not wrong. But, we were living in Azure at the time, and if we roll the clock forward to maybe 2018, we looked at the products that were available to us, and we thought, sure, maybe I'll use data lake storage. The icon here being for data lake storage Gen 1, which actually went end-of-life support in last month. So, things evolve. Data lake analytics, Microsoft have now finally announced that they're retiring it. Anyone use data lake analytics? Awesome. Anyone dedicate 2 years of their career to blogging about it and working with it? And just me? I'll go and cry in the corner with the other people that raise their hands. And for our speed layer, we might have done something with our event hubs and ultimately stream analytics here. I do love stream analytics. And then we might have served it in what was called our SQL DW at the time. So this is what we might have done. I say this is an evolution prior to Delta Lake as well, kind of importantly, because we've got our old pizza box icon, very deliberately so. We thought about that, and we thought about that Lambda architecture, and then somebody says, hey, there's a problem here. This is good. This helps us. Nathan Mars gave us a good pattern here to actually implement what we were trying to do. But somebody said, hey, there's probably a better way. And what Jay Krebs said to us was that there's a lot of complexity that goes into that Lambda architecture because we're putting a lot of the business logic in two different places for the speed and the batch layer. So what Jay said was, well, let's try and simplify that. Let's do something that's easier. Let's unify some of that compute and complexity. And he created what we could describe as a Kappa architecture. Fine. We think about those concepts and we think about the tooling again. We can redraw our picture and we can simplify and say, hey, we no longer care whether it's speed or batch. We don't ultimately care about what the velocity of the data is. We just care about ingestion. Fine. And however we do something with it in the middle, all we care about is consumption. Again, what I kind of started out in the beginning by saying, sure, data sources, data insights, something needs to happen in the middle still. We're not describing it as a data warehouse anymore, but we're talking about the tooling. And this was ultimately where, for me, Delta Lake kind of came into its own, because it had the scalability, it had the resilience. It meant that we could scale out with the storage and the compute. And we could use it to deliver this. We could throw batch data and stream data or speed data into a Delta table, and it would handle it. In Azure 2019, the tooling for me was very much a data factory, perhaps to deal with the batch data, maybe an event hub, but Databricks very much there as that wrapper over Apache Spark with Delta in it, and that was all good. That's what we needed. If we're taking the red pill, we roll the clock forwards. We evolve. Microsoft gave us the blue pill, and we might have included Synapse in here, 2021. I say 2021 because Synapse went into private preview in sort of 2019. It took a full year or so to go GA in about December of 2020. So 2021 was about right in terms of maturity and actually using it. What you've also got in here as well is the stealth bomber icon, Azure Data Explorer, very appropriate for an aviation-themed conference. So we might have used that as well, and we might have done something still to serve our data now using what was called a dedicated SQL pool. We evolved from the SQL DW into a dedicated SQL pool, and we also had a serverless endpoint as well. But ultimately, SQL endpoints for our consumption, if we wanted to. So this is that evolution, kind of on a page, if you like, as I saw it, as I lived it in my career. And I appreciate we're kind of going backwards and forwards here between the technology, the concepts, the problems, the solutions, and sure, we've got Keanu Reeves there looking over our shoulder as well. But, this is kind of where we were at. Then, enter Fabric. Now, we'll introduce Fabric firstly by thinking about the fact that there are actually different types of Fabric. Trinity here is wearing a black leathery type thing, and Keanu Reeves has got some sort of heavy cotton type coat on. Different types of fabric, right? That black doesn't really work on that projector screen. Shut up, Paul, with your silly dad jokes. Move on. Okay. What I mean, of course, is what Gartner gave us. What Gartner gave us and said, hey, data fabric, let's do that. Microsoft, of course, weren't really following that at the time. But kind of the call-outs, I would say, is that in Gartner's definition of a data fabric, they said they want the operational data and the transactional data together. Who thinks having the OLTP and the OLAP data together in the same solution is a good idea? It depends, yeah. Correct answer. It depends. Sure, I'm not sure yet, but hey, doesn't matter. We don't have to make that decision now. If we are thinking about Microsoft Fabric, what Microsoft say to us is, hey, we have an all-in-one analytics solution now. Okay. And if we kind of think about Fabric, and I give you motion sickness with animations, and we bring in that full stack, that evolution, as I say, I'm describing it to you. What we find in here, what we find in here is that we say we have this end-to-end analytics service, and the bottom one for me is very amusing. Microsoft say we are no longer stitching together these individual analytics services because it's unified. I find this amusing because when the marketing people described Synapse to us in the beginning, they used pretty much the same sentence. We were stitching together brittle things. Now it's all unified, so we don't need to stitch them together anymore. But hey, maybe they said, well, it's fabric. We have to say it's stitching. Who knows? But an evolution of the stack, nonetheless, an evolution of the tooling. If we think about what goes into Fabric, and we think about what Microsoft call those experiences, we have integration, engineering, warehousing, data science, real-time analytics, business intelligence. Business intelligence is cool again. Woohoo! No? Who's a business intelligence developer? Or who was? Yeah, we were cool once. Apparently now this yellow icon that obviously changes in terms of its shape, color, etc., but now it's cool again. But in terms of these capabilities or these experiences versus those technical capabilities, We can do things with scheduling, dependency chains. We can do things with full code using Scala, Python, etc. if we wanted to. We can build relational models if we want, using T-SQL. We can use KQL for our real-time data, DAX and M for our business intelligence. Sure, and at the bottom here, underpinning it all is our one lake storage, deliberately structured and formatted using Delta Lake tables. It doesn't have to be, by the way, but that's pretty much how Microsoft like it to be. So sure, we definitely have a unified product stack now, I agree. But in that timeline, we've had a lot of capabilities like this already. We've had a lot of this stuff already. Perhaps with the exception of Data Activator, some of that is a little bit kind of net new in terms of what we can do with it, but sure, we have these capabilities. If we think about Fabric and we think about it in the context then of what we said earlier with our Lambda and Kappa architectures, maybe now because we have things all unified together, we might include Fabric in 2024 with a picture perhaps a bit like this. We still have some integration pipelines dealing with our batch data. We now have something that Microsoft call an event stream. An event stream, for me, quite irritatingly, is just an abstract over an Azure Event Hub and Azure Stream Analytics. Microsoft have bundled it all together, took away all the good functionality and called it this new thing. Hey-ho. We have our lakehouse, we have our SQL endpoints, and maybe we can consume it. So sure, this is how we could think about a Kappa architecture in the present day. Maybe. We shove everything up and we say, yes, we've got now some alternative flavors in here in terms of what we might want to do. So that evolution of concepts and tooling. Along came the mesh. Who likes data mesh? A few people. Mixed room. It's all good. So what is the data mesh all about then, hey? Well, I think the fundamental difference in terms of what we talked about so far is that, sure, you know, we've talked about concepts and technology. For me, when somebody says to me about a data mesh, I have to use this Venn diagram. I love representing things as Venn diagrams. But we have to think about not just now the technology, we do have to think about the people and the process as well. We have to think about all of the culture, the personas, the structure, etc., all of the ways of working and governance and who knows what and maturity and frameworks. It means ultimately that then that overlap in the Venn diagram where we might actually see that data mesh emerging becomes very, very, very hard. So hard, in fact, that Gartner will give us hype curves that says, hey, data mesh is now dead, or you know, there's no longer any hype around it. I don't think it's dead. I think it's just very hard, and so hard, in fact, that as an entry point, some organizations really struggle with it. Because if you're going to go after all those things, you need to start restructuring your teams and restructuring your organizations and all of that other stuff that needs to come before it because of the people in the process as well. So it's not dead, it's just very hard. It's fine, because today we're only talking about technology. We can focus on technology. We could go much deeper with data mesh in all those other areas as well, but we'll focus on the technology. Now, of course, we can't talk about data mesh without mentioning this lady, Zhamak Dehghani, I believe is the correct way to pronounce it. And of course, what we know from Zhamak is that she gave us these 4 principles. Domain-orientated, decentralized data ownership and architecture. Whew, that's a big one. Data as a product. That one was slightly easier because I think we could argue that we've been doing data as a product for a long time now. What is a data product is certainly a question that is up for interpretation as well. That self-service data infrastructure as a platform, that's another hard one. We're focusing on the technology now, and it's getting even harder. And federated computational governance. I'm very glad that she stopped at 4 principles. I'm not sure we could have taken any more. And of course, you may have read Zhamak's book, on creating a data mesh. Now, this is all good, but ultimately, we've been talking about technology a lot. I say we're talking about technology a lot here. Zhamak's book and Zhamak's principles are not about technology. They're very much about ideals and about having that North Star of how we could do things, how we might want to do things, which is fine. I think it's great to have that North Star, but I have to live in the real world. I have to build things for my customers using Azure. So I went on a bit of a rant and a tangent on my blog of comparing the theory of data mesh to the actual practical implementations of it. But all those things aside, if we consider that data mesh in the context of my first reference architecture, slightly tweaking the colors here, and we say, well, why should we care? Why should we build it? I think about if we extend my first reference architecture into the real world, and a little bit kind of playing on what we said earlier, from our data source to that data insight, we might do a bunch of this stuff, and we might ask our data warehouse to do these things, but we've decoupled a lot of things now in Azure using the cloud technology that we have. So to get there, we have tried over the years to implement frameworks and code accelerators to integrate and embed and use things like AutoML and abstract things and using serverless and everything that ends in ops, DevOps, DataOps, MLOps, make my dinner ops. But ultimately, what we could say is that, there's a lot of good technical maturity in here, but we could argue that we end up with a bit of a monolith. Not necessarily wrong, but what it does mean in that monolith that we see a lot of common problems. Common problems where we have a lack of quality, we have bottlenecks, we have centralized IT teams, and we have a lot of governance. Again, not bad, it's technical maturity, it's just how we've evolved. That's fine. But if we were to describe it as this centralized system, it's a problem. So I'm answering this question for you of, well, why should we build it? Well, this is the starting point for that answer. Ultimately, we need to strip away some of that complexity. We need to try and get a lot closer to that data insight. We need to package it up. We need to make it smaller. We need to make it so we can then define what is ultimately a data product. And we can get there with that insight much quicker. Land the data, have a quick look at it, get the business users to consume it, get that insight from it before we go through all of those steps of maturing it. And if we do that, ultimately, we can scale, we can decentralize, we can create lots of these data products and we can wrap them up in a domain. We can use our technical goodness to onboard more data products a lot quicker. And we can serve things then maybe through a marketplace. Now, what I'm ranting at you about, I don't think is anything new, because from that marketplace we create a nice abstraction, maybe in the terms of a search engine, maybe Google, maybe ChatGPT, an abstraction over all of this complexity, which means that we can now serve on that data with ease. We can get the insight from it quickly. The internet, we might say, quite literally organized as domains. We have our search engines. We no longer need books of Encarta and Britannica on our shelves. We have a search engine that makes all of that data come together. We basically need to achieve that same thing for our internal data platform systems. So we could describe this as that decentralized architecture. Not perfect, slightly overly simplified for what we're talking about now, but to answer that question of, well, why should we build it? For me, the answer is that time to insight. That time to insight on the left versus that time to insight of our picture on the right. We could argue that on the left, that time to insight is a magnitude of weeks, months. On the right, it's more like days or hours, hopefully. So this is my answer to you today about why should we consider building that data mesh, because I have seen that we can get there much quicker with that time to insight. It takes a lot of effort, it is hard, but we can get there. So if we now think about, okay, we've got many data products in here, and I said to you that definition of a data product is probably going to be the hardest starting point. I like to, as I've said, use things as, represent them as Venn diagrams. I think it's very important to describe what is a data product. I also think it's very important to describe what is not a data product. So I've been to customers where they say, hey, I've got a monolith. This is my data product. And I said, well, what is your neighbor doing? What have they got? And they said, oh yeah, I've got a data product as well. Meaning then there's then no consistency in there. So I say, okay, fine. Well, if you've not got consistency, you've not got these standards, you know, the people and the process problems, then you're not going to have your data mesh. You've just got people working in isolation, which is, again, another very real danger of going down that data mesh pattern. You end up with silos. You end up with anti-patterns because people go off trying to do their own things. We need to decentralize to get the time to insight quicker, but ultimately control and having that federated governance as well. Definitely a bigger topic for another time, but let's simplify. Let's get back on track and think about it in terms of our technology. Again, I've been playing the ideals game a little bit. I'm going to say I've got 4 data products. They're going to be represented here quite simply as 4 Azure resource groups. Do I have a mesh? No. They're isolated at the moment. They're siloed. Nobody knows what the other one is doing. So in order to achieve that mesh, certainly in Azure, we need some interfaces. They need to talk to each other. They need to connect. They need to understand what each other is doing. Purely in Azure, again, at this point. Now, for me, the way I like to think about those interfaces and how I've actually helped my customers build them is we describe them as our primary interfaces, firstly. Interfaces where the focus is data integration and exchange. Now, whatever that technology, whatever those products are that we're using in there to achieve that data processing and handling, as long as we have consistency in that output, and I think over the years, SQL has stood that test of time as a language that we could use as that endpoint and that interface to work with whatever is going on in that data product. Surfaced in T-SQL, Spark SQL, I don't mind, but as long as we have consistency with those primary interfaces, this is what we might do in Azure. We might have some secondary interfaces. Interfaces here where we do have to understand that there is a developer and an operational team. We don't just throw things over the fence. We need to help the ops team. So the secondary interfaces, I focus on the operational reporting, what they actually need to do with the logging, the telemetry, the monitoring. All of our Azure resources now will give us diagnostic settings to send the telemetry to something like Log Analytics that we can then query with KQL. We can have Log Analytics instances localized to the data product. Maybe we have Azure Data Explorer instances that cover an entire business domain or something in between. But if we have SQL as our endpoint for our primary interfaces, KQL feels like a good endpoint for our secondary interfaces. This is the theory versus actually doing it. And then lastly, we have to think about the networking. All data engineers now also need to be network engineers, so it would seem. Because in an enterprise, we need the VNets. We need those TIE fighters and little TIE fighters as well. Pew, pew, pew. Databricks clusters need massive amounts of address space and VNets to operate, so Spark can do what it needs to do when it scales out over that distributed storage. Enterprises don't like it when you ask them for 65,000 IP addresses. They say to you, you can have 5. It's like, well, your cluster's not going to get very big then. Your data processing is not going to go very fast. So this is what I'm saying to you. Data engineers, they might need to be network engineers as well to at least help broker those conversations with IT around the networking problems. But this is, I say, a slight tangent here of if we're considering a data mesh architecture, we're considering the technologies versus the ideals and how we implement it, this is what we could do in Azure. If we think about the data domains in Azure, the actual practical implementation of them, we could do something fairly simple here, and we could actually say, well, we've got our Azure resource groups. We could say that I'm just going to create a subscription for those business domains. Now, we'll always have trouble defining in a large organization what those business functions, what those business domains are, but at least when it comes to Azure from a cost perspective, from a charging model perspective, having that subscription level separation can help us. What you'll also find as well in Azure at a subscription level is you have limitations on role-based access controls, on things like the number of CPU cores you can deploy based on soft limit quotas that Microsoft put on at the subscription level. So easy to draw a picture of it, but also it makes pretty good sense in terms of how we practically define it. And then, of course, we can scale. We can scale out our business domains with legal and sales and finance and operations and all those good things. Now, this is very much an Azure-focused picture. The technology kind of feeds in here as well, right? We have to consider now Fabric, which is an interesting problem if we think about Fabric versus that data mesh. If we think about what I told you earlier in terms of what Fabric gives us with those experiences, all of the goodness, but what we know about Fabric in terms of how it's organized is that we create things in workspaces. Workspaces where we grant our users access and things, and we've organized ourselves in this way for a while now using Power BI. This company here is very good at helping you organize those things, by the way. The things that we build in those workspaces, those items that help us do that integration and create that lakehouse, etc. If we think about them then in the context of Fabric domains, and this is what Microsoft tell us. They say here we're considering federated models. This federated data architecture is called a data mesh. I was like, oh, is it Microsoft? Is it really? I'm taking the mickey slightly, of course, but I think this was a good thing. It was a good thing now because we actually have a software vendor leaning into the concepts of a data mesh architecture. Great. Maybe they're leaning into the concepts of a data fabric architecture as well, to bring fabric and mesh together. Who knows? We'll see. But in the context of now, what we can say is that yes, within Fabric, we have this way of logically grouping together all of the stuff for our organization into a particular area or a particular domain. Which means that for our items, we can have another Venn diagram where we can organize things. We say, yes, these items belong to this domain, these items belong to this domain. And if we would consider it as a hierarchy, we've got our Fabric, we've got our OneLake, we've got our domains in there as that kind of logical grouping, as we say, that virtual level that helps us kind of get there and organize our workspaces and our items. So let's recap, let's wrap up, let's come back to kind of where we started. This was always going to be a hard session in 50 minutes, but if we think about that agenda and we think about how I've introduced these things for you, hopefully this order kind of makes a little bit more sense now. The concepts, the technology, the evolution, the backwards and forwards, I appreciate. There's a lot that goes into it. Final thoughts then. Final thoughts from me. This is where we started. That evolution of those data platform architectures as I'm presenting it to you, very much based on my experience and my career. And if we summarize and we think about that order, that evolution, was this a straight line? Maybe from Lambda to Kappa, sure, you know, that felt like a good natural evolution, combining that logic. But what we might also say is then, well, that Kappa architecture really didn't come to fruition until we were given the abilities of what Delta Lake gave us in terms of storage distribution, those ACID transactional capabilities. Do we evolve to a data mesh? Is that the natural evolution? Is it an obvious evolution for every organization? I don't think so. It's not right for everybody. It's got a high bar to entry. But what we could probably try and do, or try and appreciate, is that from all of that goodness that came before it, in terms of the symbols, feeding them into what goes into the data products of our data mesh, sure, we could go after that. Now, what Microsoft give us with Fabric, sure, there's some understanding there if we're going to build that. We might still go after a data mesh, but are we going to build Fabric on top of a data mesh, or is Fabric really just leaning into those concepts of a data mesh by virtue of how the product lets us organize ourselves with the contents of what we're building? Another very key question, did Keanu Reeves create these films in the right order? Was The Matrix 4 a big mistake? Who knows? But hopefully I've convinced you that he is a data engineer. Another thing that we've not discussed, and something that I do tend to get asked when I deliver this session is, well, what about a medallion architecture? Medallion architecture is not an architecture. It is pretty much the only thing Simon Whiteley and I actually agree on. It's not an architecture. It's a series of definitions and a way that we could, if we wish, organize the layers of our storage. This is currently my perspective on a medallion, not architecture, if we're considering Azure and Fabric. Fabric is obviously still on that maturity curve. It's got a long way to go in terms of getting there, but here's a blog post for you, and I'm sure things as the evolution continues will make sense or won't. We'll see. And then last question, should we be considering a solution/technology stack that offers all of the capabilities that I've described to you today in something that is then that Nirvana-type platform? What's the answer to this question? It depends, sure, but I'm going to be brave, people. I'm going to say, yes, we should. I'm not going to go, it depends. I'm going to say, yes. And with that, I will say thank you very much for listening. This is the game that I like to call, see if your phone can deal with multiple QR codes on a screen. The top left, of course, session feedback for the conference. I'd very much appreciate your thoughts. Feel free to connect with me in that top one there. Feel free to reach out to my company as well. More than happy to help you if you've got projects and things that need support. And then, as promised, I didn't give you a fourth QR code, but cloudformations.org/community content. There's already a PDF there of everything that I've just shown you. Thank you very much.